All right, this is talking about critical points, chapter 4, section 1. So remember, a critical point is everywhere the derivative equals 0. So where I could draw a horizontal tangent line right there, 1, 2, 3, 4. So that's how we can see those are 4 critical points. The minimums would be the low ones, so that one, or we could say the concave up, and then the max would be the 2 concave down. Something like this says, during an illness, a person ran a fever, his temperature rose for 16 hours, and then it went down, so that would be your max, would be your critical point. I'm going to jump to this one, and then I'll go back to that. This actually is just like, like your group work. So wherever the derivative, notice this is the derivative, so when the derivative is negative, it's decreasing from 0 to 3, so it's going down. And then it starts to increase to go up, so it's going down and goes up, and then it's going up, and then it comes back down. So it says right here, demand is decreasing from 0 to 3. Okay, so from 0 to 3 because it's negative, and then from 6 to 10 because it's negative, and then it would be increasing from 4 to 5 because those are the only positive values. And then it asks where the max and min would be. Well, remember, this is decreasing to increasing, so that would be a min between 3 and 4. And then increasing to decreasing would be a max from 5 to 6, and that's what that's saying. All right, so the last one here says this function has a critical point at x equals 1. Use the second derivative test to figure out if it's a max or min. All right, let's do it. So if I get me some kind of color scheme going on here. So I'm given f of x equals x to the 4th minus 10x cubed plus 26x. And it says your critical point is at x equals 1. And it wants to know if that critical point is a max or a min. And it says use the second derivative test. So apparently, I got to find the second derivative. So the first derivative, 4x cubed minus 30x squared plus 26. Gotten good at them power rules, right? And then the second derivative would be 12x squared minus 60x. And now it says at the critical point, x equals 1. So you simply just plug in a 1. And as we can see, because certainly the negative is on the larger value, at the end of the day, I don't even care the answer, the numeric answer. All I care is this positive or negative? And it is definitely a negative value. When the second derivative is negative, makes it sad, right? And so that's why you would have a local max at that value.